So in this video, we're talking about something a little different. These are not polar and nonpolar bonds, these are polar and nonpolar molecules. And so the definition of a polar molecule is similar to that of a polar bond. It's a polar molecule is where the molecule itself as a whole has unequal electron density. One side of the molecule has more electrons on it than the other side of the molecule. Those electrons are not spaced out evenly or symmetrically, because that's what a nonpolar molecule is, where the electrons are spaced out equally. It's very symmetrical. So an example of a polar molecule here is water. And if I look at water, I was going to draw the Lewis dot structure of water, kind of look like this, and it would have its lone pairs up at the top. And even though it may be symmetrical this way, I notice that this way it's not symmetrical. One side of that molecule has the two hydrogens on it, and the other side of that molecule has the two lone pairs. And lone pairs of electrons are very negative. So the top of this molecule, the oxygen side of this molecule, is where the electrons spend most of their time. So the top of this molecule, the oxygen side of the molecule, is a little bit negative or delta negative. And the bottom side of this molecule is delta positive or a little bit positive. And that's what this picture here is showing, just with like a rainbow of colors, red being where the electrons spend the most time. And then this diagram down here shows you three examples of polar molecules. And again, this is water, and it's really polar because it's bent shape, because one side of the molecule is much different than the other side of the molecule. This molecule right here, CCl4, in its Lewis dot structure may not look all that different. It looks like kind of a cross. But remember, this is really a tetrahedral structure. And all of these chlorines are pulling the electrons, but they're pulling them with the same amount of force. They all have the same electronegativity. So that molecule would be nonpolar. And then this other molecule here, this is ammonia, or NH3. And NH3, again, has a lone pair of electrons on the central atom, and those lone pair of electrons on the central atom, and the fact that it's trigonal pyramidal, means that this molecule is not symmetrical, and one side is more negative than another side.